Hello, my name is Dr. M. Santosh Kumar, Assistant Professor in Mathematics, Department of Registerman Engineering, St. Martin's Engineering College. Today, I will discuss the topic is Fourier series and its applications. The main contents of this topic is Fourier series and even function and odd functions, half range cosine and sine series, and change of interval. The applications of Fourier series is force oscillation and heat inductions. First of all, Fourier series. What is the Fourier series? Who invented the Fourier series? Fourier series is invented that technique of using trigonometric functions sine and cosine is known as a Fourier series, and to solve the differential equation of the heat induction. Next one is, what is the Fourier series? Fourier series is an infinite series representation of periodic function in terms of sine and cosine and of its multiples of an angles and its multiples. Okay, we know that the Taylor series is another series to expand the function of the series, but Fourier series is possible to solve continuous functions and periodic functions and the continuous differentiation and values of the differentiation of the values. And Fourier series is also most powerful method to solve the ordinary differential equations and partial differential equations, and particularly with periodic functions as appearing non-periodic functions. And next one is, what is a periodic function? A function f is said to be periodic, and if there exists a smallest positive integer t such that f of x plus t equal to f of x for all x in domain. This is the illustration is the periodic function. This is the periodic function. The period is 0 to 2 pi and 0 to 2 pi, and the passes through 0 to 2 pi 4 pi, the limit is 2 pi, and the function is as y equal to sin x function. That is the sin x. The sin x function is the wavelength is 0 to 2 pi. This is the 0 to 2 pi, and the length is 0 to 2 pi. The wave is completed is one wave. This passes through the origin 0 to 2 pi. And next one is cos x. The cos x is passes through the y axis only. The limit is 0 to 2 pi. The interval is 0 to 2 pi. This is the main trigonometric functions in Fourier series is sine series and cosine series. This is the Fourier waves. These waves are sum of sine series and cosine series. This is the square wave, and this is the 3D view. The waves are passing through the limits 0 to 2 pi. And next one, the Fourier series generally form as f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity b n sin n x. Okay, the limits is a naught, a n, b n are the coefficients of Fourier series to get the solution of the Fourier series. This is the a naught equal to 1 by pi integral minus pi to pi f of x dx, a n equal to 1 by pi integral minus pi to pi f of x cos n x dx. This is the second, and bn equal to 1 by pi integral minus pi to pi f of x sin n x dx. These are the Fourier series using orthogonally relations of sine and cosine functions. Next one, basis formula of Fourier series. The Fourier series of the periodic function f of x with period 2 pi, where a naught, a n and b n are known as the Fourier coefficients. The determined 1.1, the 1.1 is a naught equal to 1 by pi integral minus pi to pi f of x dx, and bn, a n similarly, a n, b n also Fourier coefficients. This is the individual term of the Fourier series are known as a harmonics, and every function f of x of period 2 pi satisfying the following conditions is known as a Dirichlet conditions. The Dirichlet conditions can be expressed as these conditions are. The main Fourier series Fourier series to satisfy these conditions is f of x bounded and single valued. That means a function f of x is called single valued if each point in the domain it has a unique range. The unique range means this is the every function have a range or interval. The second point is f of x has at most a finite number of maxima and minima in the interval. Maximum and minimum intervals in the Fourier series, the each function. And third point is f of x has at most a finite of discontinuous in the interval. This is the example. We take one example, sin inverse x. We can say that the function sin inverse x can't express it as a Fourier series because it has a non-single value. This is the, and tan x also, the interval 0 to 2 pi cannot be expressed as the Fourier series because it is an infinite series, x equal to pi by 2. And Fourier series for even function and odd function. Even function. Even function means if a function f of x is said to be even function, the condition is the period is 2l minus l comma l less than or equal to x less than or equal to l, then f of x cos n pi x by l is even, while f of x sin n pi x by l is odd. Okay, thus the Fourier series is an even periodic function with period is 2l minus l less than or equal to x less than or equal to, given by the main function is, if even function in the Fourier equation is only for f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos pi n x by l, and a naught equal to 2 by l. This is the even function. Even function only to find the Fourier coefficients are a n and a naught, a n only. B n must be 0. Then the graph representation is an odd function. If a function f of x is even periodic function with the period 2l minus l less than or equal to x less than or equal to, then f of x cos n pi x is even, f of x sin n pi x by l is odd. Thus the Fourier series expansion of an odd periodic function is with period 2l minus l less than or equal to is given by, in the odd function we can find the only bn only, an and a naught must be 0, where f of x equal to summation n equal to 1 to infinity bn sin n pi x by l, where bn equal to 2 by l integral 0 to l f of x sin n pi x by l dx. This is the n equal to 1 to so on. And next one, half range cosine series. Half range cosine series is nothing but the limit is, the interval is to taken as a 0 comma pi is f of x equal to a naught by 2 plus summation n equal to n to infinity a n cos n x, and where a naught equal to 1 by pi integral 0 to pi f of x dx, and a n equal to 1 by pi and integral 0 to pi f of x cos n x. This is also only to half range cosine series to find the a naught and a n coefficients only. And half range sine series. The half range sine series of the function f of x is 0 comma pi is f of x equal to summation n equal to 1 to infinity bn cos n x, where bn equal to 1 by pi integral 0 to pi f of x sin dx. And to take one example, if f of x plus 2 pi equal to f of x, find the Fourier expansion f of x in the interval 0 comma 2 pi. Hence otherwise prove that the series is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus so on equal to 1 by 4. To prove to solve this problem, by using notepad, the given function is solution. The given f of x equal to x, and in the interval 0 comma 2 pi, then the Fourier series of the function of the function the general form is f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity and bn sin nx, where a naught equal to 1 by pi integral 0 to 2 pi f of x dx equal to 1 by pi 0 to already given f of x equal to here x dx equal to 1 by pi integral 0 to 2 pi equal to the integration of integral x dx equal to the formula is x square by 2 plus c. Okay, here integral x dx equal to x square by 2 limits 0 to 2 pi 0 to 2 pi, that is the equal to 1 by pi integral 1 by pi x square by 2 0 to 2 pi. The limits is upper limit is first you substitute upper limit 2 pi whole square by 2 minus 0 by 2. There is 1 by pi 4 pi square by 2 minus 0. This is the to cancel 2 1 by pi equal to 2 pi square pi cancel. This is the 2 pi. This is the a naught coefficient. The a naught coefficient value is a naught equal to 2 pi, and another coefficient is an plus 1 by pi integral 0 to 2 pi means f of x cos nx dx already given the f of x equal to an equal to 1 by pi 0 to 2 pi x cos nx dx. This is the udv. We are using udv formula, that is the uv formula. Here integral uv equal to u integral v minus integral u dash v1 integral v. This is the formula for integral uv, and we applying the formula in the integral 1 by pi integral 0 to 2 pi x cos nx dx. That is here we are using here 1 by pi where u is a x and v is a sin nx. This is the x integral cos nx dx minus integral x means u dash means derivative of x equal to 1 integral cos nx dx. This is the 0 to 2 pi. Okay, 1 by pi integral x to integral cos nx means sin nx by n minus again integral cos nx sin nx by n dx. This is the limits is 0, 2 pi. Okay, again equal to 1 by pi integral x sin nx by n minus integral sin nx by n dx. This is the resultant 1 by pi x sin nx by n integral sin nx means minus cos nx by n minus cos nx by n square limits 0 to 2 pi equal to 1 by pi x sin nx by n minus into minus plus cos nx by n square 0 to 2 pi. 2 pi. To apply the first 2 pi is the first upper limit. Again, next to substitute lower limit 1 by pi. 1 by pi. To first substitute 2 pi sin n 2 pi. Sin means sin n 2 pi means this is sin n 2 pi means equal to 0 and cos 2n pi equal to 1. This is the values. Sin 2n pi equal to 0, cos 2n pi equal to 0. This is the first substitute 1 by pi x. This is the x into sin n pi. First substitute 2 pi into sin 2n pi by n plus cos n 2 pi by n square minus 0 into sin n of 0 by n plus cos n of 0 by n square. That is the 2 pi sin 2n pi equal to 0, cos 2n pi equal to 1 by n square minus 0 into sin 0 0 and plus cos 0 1. That is the next substitution equal to 1 by pi 1 by n square minus 1 by n square equal to 0. In the Fourier expansion, an must be 0. And to find the bn coefficient, 1 by pi integral 0 to 2 pi f of x sin nx dx. Sin nx dx, this is the coefficient, bn coefficient is 1 by pi integral 0 to 2 pi f of x sin nx. This is the 1 by pi integral 0 to 2 pi f of x means given already sin nx dx. We are applying another again integral udv formula. Integral udv equal to u integral v minus integral u dash integral v again 1 by pi x into integral sin nx dx minus integral u dash means x, derivative of x means 1, and integral sin nx dx equal to 0 to 2 pi equal to 1 by pi x. Integral sin nx means minus cos nx by n minus, here also integral sin nx means minus cos nx by n dx, limits 0 to 2 pi 1 by pi x minus x cos nx by n minus into minus plus integral cos nx by n dx 0 to 2 pi, and 1 by pi equal to minus cos nx by n. Again integral cos nx is sin nx by n square. To apply the limits 0 to 2 pi, and 1 by pi first you apply the upper limit is in place of x 2 pi cos n 2 pi is similarly since cos n 2 pi equal to 1, sin 2n pi also 0. Here we substitute 2 pi and next 2 pi 1 by pi minus x equal to 1 by pi minus 2 pi cos 2n pi by n plus cos sin 2n pi by n square. Again substitute 0 cos 2 into 0 by n plus sin 2n of 0 by n. This is the here to observe that cos 2n pi is value 1 and sin 2n pi value is 0, and cos 0 is 0, but this term must be 0, and remaining term is equal to 1 by pi 1 by pi 1 by pi minus 2 pi by cos 2n pi equal to minus 2 pi by n. This is the remaining resultant equal to minus 2 by n. Okay, this is the find out the coefficients. This is the Bn coefficient. A naught equal to 2 pi and An equal to 0 and Bn equal to minus 2 by n. This is the coefficients of this taken problem, and the final resultant is f of x equal to x and a naught by 2. A naught by 2 means here a naught equal to 2 pi by 2 plus summation n equal to 1 to infinity. An value is 0 cos nx plus summation n equal to 1 to infinity. Bn value minus 2 by n and sin nx. Okay, that is the x equal to pi minus 2 summation n equal to 1 to infinity sin nx by n. This is the series of the given example. Okay, to find the series, substitute, put n equal to 1, n equal to 2, n equal to 3 in the series. That is the pi minus 2, put n equal to 1 sin x plus by 1, next sin 2x by 2, next sin 3x by 3 plus so on. This is the up to infinity. Then to make a series is x equal to 2 minus sin x plus sin 2x by 2 plus sin 3x by 3 plus so on up to infinity. Okay, we get the solution x equal to, substitute x equal to pi by 2. That is pi by 2 equal to 2 minus sin pi by 2 plus sin 2 into pi by 2 by 2 plus sin 3 into pi by 2 by 3 plus so on. To substitute the sin pi by 2 value is 1, sin 180, sin 270 is minus 1. The series, to get the series is 2 minus 1 minus 1 by 2, 1 by 3 plus 1 by 5 minus, to get the solution pi by 2. That is the, to get the solution is pi by 4 equal to, take common, there is the 1 minus 1 by 3 plus 1 by 5 plus so on. This is the resultant of the example. And next one is finder. The PPT is okay. Next one is in the Fourier series. In the Fourier series, to find different ranges, that is the 0, 2 pi, 0, pi and minus pi 2, pi and 0, 4. This is the normal Fourier series using for generally. Fourier series is generally, this is the 0, pi, this is the half range, this is the half range and cosine series, half range cosine and sine series, cosine and sine series. And next one is minus pi to pi is the even function and odd function, even function and odd function, and this is the change of interval. This is the interval is 0 comma pi is the change of interval. This is the Fourier series, and the process is this is the final series, and to get the solution is example f of x plus 2y equal to f of x. Find the Fourier series f of x equal to get the series is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 equal to pi by 4. The resultant is. And next one, applications of Fourier series. What is applications of Fourier series? The first one, forced oscillation. Forced oscillation means to get the oscillations of forced to observe the diagram. This is the oscillation to form a wave. This is the trigonometric wave. This is the trigonometric wave to force the oscillation. And the to observe this diagram, to observe that a mass spring system before where we have a mass in a spring with constant K. This is the constant K, and damping C. This is the damping C, and a force F of T. And force F of T. Suppose that f of t is periodic function. This is the equation. Main equation is m into x double dash of t. There is one plus c into x dash of t plus k into f of. This is the application part, and this is also the main formula is x of t equal to a into cos wt omega t plus b sin of t. And next one is this is the video for the Fourier series. This is the square wave. This is the square wave. The period is equal to, this is the over and after the up and downs. This is same, the wavelength is to adding the functions. This is the sin x function. This is the video is sin x function, and that is this is one sin 3x function. The period is 0, 2 pi. Yeah, the sum of sin x plus sin 3x is, this is the point of contact. This is the point of contact. This one is point of contact. This one is to add these two functions. Add these two functions. Add these functions to the sin pi by 2 value is this pi by 2. Sin pi by 2 value is 0 and sin 3 by 2 value is 1 by root 3. This is the square wave, the nearest closest of the square wave. This is the another series. To find that, next one is in the 3D motion. In 3D, the time amplitude to transform to the frequency in 3D view, the points are to x-axis again to reach the waves. This is the view. The 3 by 4 sum of two functions is 3 by 4 sin theta plus 1 by 4, and application part is this is the force oscillation to move the resonance, and this is the now suppose the 2 also two sine waves also different ways. This wave to transform it into sin x pi equal to 0.5, 0.2 comma, that is that sin 3 by 4. The view is in the wave transformation is, that is 3 by 4 sin theta plus 1 by 4 3 theta. Two waves, the resultant is no longer a sine wave. That is the next wave to transform to the sine wave and cos wave. Okay, this is the sine wave, and next one is oscillation. The push into once the main resonance is forward to or reach in time, the total energy of the system keeps decreasing to makes the level of the zero to take this point. This is the force oscillation to reach the minimum point and maximum point. This is the reaching point, and this is also to reach the square wave. This oscillation sin x and sine wave, this is the sin x wave, this is the minus 1 by 2 sin 2x wave, sin 3x wave. This is the to make the sawtooth wave, to reach the sawtooth wave in terms of the sine and cosine. This is the to reach the sawtooth wave. This approaches that the amplitude time to reach the waves. This compression 3 by 4 sin theta plus 1 by 4 sin theta. This is the resultant. This is the sine wave. This is the cos wave to reach the spectrum. Okay, this is the spectrum. Today we discussed the topic in this class. Thank you.